Hi everybody. This is an introductory video for calculus, and I'm introducing what's called the derivative. So there's a few prerequisites that we should get out of the way before we do anything else. So let's do that right now. So let's suppose I have some function f of x, and let's just say, for example, we can draw that here. Here's f of x, a nice smooth curve, and let's just say that this is 3. That makes this, and let's just say that the y-coordinate when x equals 3 on this particular function, let's just say that's 7. So I'm completely making this up. But basically what that means is, when I write this, I can say that f of 3 is equal to 7. So the notation, for those of you that aren't familiar, I'll do a video on this, but this would be more classified as an algebra type video, and I'm just making sure everybody's okay with this before we actually start the derivative in calculus. So basically this is the x-coordinate, this is the y-coordinate. I guess you could simply say that y equals 7, right, and leave it at that. But the f of notation is a little bit more robust, and as you're going to see later, we're going to need it. So that's the first thing. Make sure that you understand the f of notation. Another thing that I have to say is this, and I find it important because it's an easy mistake to make. If you have a function like, let's say f of x is equal to x squared, okay? If I do f of 7, well, that would be equal to 7 squared, which I know obviously is 49, right? If I said f of 2, that would be equal to 2 squared, which we know is 4, etc. Now, if I say f of, p, well then, in the same way that I plugged the 7 in for x when I did 7 squared, I'd plug a p in, so that would just be p squared. And if I said, hey, what's that for this particular function, if I said, what's f of happy face, that would just be happy face squared. Okay? Now if I say, this is the more important part. If I say f of a plus b, well, that would be, according to this function, since f of x is just x squared, that would be a plus b squared. And I want to be very clear about something. So this is important, and like I said, it's a mistake I see a lot of people making. It needs to be clear to you that f of a plus b is not equal to, in general, f of a plus f of b. In other words, this function notation is not multiplication. Okay, that's not what it is. It's a special notation for functions, and these two things are not, this thing here is not equivalent. Now, it's easy to show that, and let's just stick with our function that we're talking about, f of x equals x squared. So in this case, f of 5 would be equal to 25. Now, if this thing here were true, right, then that would mean f of 5 would be the same thing, right? That's equal to the same thing as f of 3 plus 2, which would be equal to f of 3 plus f of 2. Now let's just see if that's true. F of 5, we already know, is 25. Now f of 3 is 9, and f of 2 is 4, and if I add those together, I only get 13. And these things are clearly not equal, okay? So again, one more time very quickly, because this is going to come up in a bit. F of, let's just say, box plus triangle is not, in general, equal to f of box plus f of triangle, okay? So I'm going to use that later on this video a little bit, but just make sure that that's okay with you. All right, now, let's say this is going to be super important. Let's say I have a point here, okay, and that point is, let's say it's 2, 4. And then I have a point over here, okay, and let's just say that that point is 7, 7, okay. Now when I draw this in, and I want to know what's the slope of that segment that I just drew, I think at this point, if you're in calculus, you should be okay with the fact that you're taking the difference in the y's, y2 minus y1, so this is going to be 7 minus 4, and you're comparing that, you're making a ratio of the difference in the x's, 7 minus 2. Okay, so in this case, slope would be 3/5 for that line. Now, with calculus, slope is a major thing that comes up, and this is going to be the basis of the derivative. So the first thing that I want to accomplish, well, one of the things I want to accomplish with this video, sort of getting prerequisites out of the way, is this. All right, so let's say I have some curve, and it's f of x, right? Now, if I say that this is a, that means the y-coordinate is f of a, right? So the equivalent back up here, this would be 2, and this would be f of 2, in that case, if we were plotting a point, right? So there that is. Now let's say over here, this point, let's say that's b. That would make that f of b, all right? Now, if I drew that line in that passes through those 2 points, and I wanted to know what the slope of that line was, well, it's really no different than this. The only thing that's a little different is, it's all symbols and f of notation, but don't lose sight of what it is. When I say f of b, that's just the y-coordinate when x equals b. When I say f of a, that's just the y-coordinate when x equals a. So what would the slope of that line right there be? Well, if this point is b comma f of b, and this point is a comma f of a, then the slope would just be f of b minus f of a, all of which is over b minus a. So that's one way to write that slope, all right? Now, when you get there in a video or two from now, I don't want you to be intimidated by that expression, and I'm actually going to do another expression that's equivalent to that right now. Okay, so let's do this a slightly different way. So let's suppose I've got, draw pretty much the same function. Okay, so here it is. So here's my function f of x. And let's say now that this is a, and that's going to make this f of a. Okay? Now instead of calling the other one b, let's just assume for a second that we add some number. I'm going to call it h. And that would make this coordinate right here, that would make that a plus h. And then, by what we've been saying, that would make that point right there f of a plus h. Now this is what I was saying before. Don't be tricked into distributing that f, because you can't do that. That's not a thing. This is function notation. So this point right here is a plus h, comma, f of a plus h. And then this point right here is just a, comma, f of a. So what's the slope? Let me draw the line in. If I actually drew the line in, what would the slope of that line be? Well, just slope formula, right? F of a plus h minus f of a. That's nothing more than the difference in the y's, divided by a plus h minus a, which the a's are going to cancel out, and you're going to be left with this expression for the slope of that red line. F of a plus h minus f of a, capital A, over h. And that's just another form for the slope of that line, depending upon the points that you're given. All right, so this is video number 1. These are some prerequisites, important. Make sure you go back, review them, etc., 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 and I'll see you in the next one.